today we're going to talk about ellipses. The word you learned in elementary school is oval, right? Not a circle, but an oval. One side's one diameter kind of is longer than the other. Yep. Okay, and the formula for an ellipse looks like this. Okay. The thing that makes it uniquely an ellipse is the plus. Now tomorrow we're going to do hyperbolas, and those are going to look just almost exactly like this, except it's going to be a subtraction. So that's really the only difference between the formula-wise between an ellipse and a hyperbola is an ellipse has a plus here and a hyperbola has a minus there. So you have to have a plus. The other thing about an ellipse is it has to equal 1. Like you have to rearrange the formula so that it equals 1. Okay? But everything else is the same. H and K stand for the center. Good, loud and proud, center. Right? H and K are the center. And then A squared and B squared are how long I hate to say the word diameter because it's not really diameter, but across the middle going this way and across the middle going this way. Okay? And A goes with X, so it's going to be moving left and right because doesn't X go left and right? Right? And B goes with Y, and it means it's going to be the measurement up and down. So the square root of A is going to tell us how to go left and right, and the square root of B is going to tell us how to go up and down. Okay? And then it's going to be just like a circle. Find the center, count left, count right, count up, count down, sketch in your circle, your ellipse. Okay? All right. So I feel like doing one is probably the best way to demonstrate it. So first of all, like this is the hardest one I can think of. What's wrong with it first? It's not equal to 1. So what am I going to do? Well, I could subtract 99. That makes it harder. Divide by 100. That's the other way, right? Either way would work, but dividing by 100 is going to make the math easier later. So I'm going to divide by 100 on both sides, because you can't just do one side. 100 divided by 100 is 1. So there's that taken care of. Now, on this side, I have 4x squared divided by 100. Okay? And I want to reduce that. I want to get rid of this number on top. So do 4 and 100 have anything in common that I could reduce out? 4, right? They're both divisible by 4. So I can divide out a 4 on top and a 4 on the bottom. And I get x squared over 25. Okay? Then I have to do the same thing with the y. I get 25 y squared over 100. Do 25 and 100 have anything in common? 25. So I'm going to divide top and bottom by 25. And that gives me y squared all over 4. So I have x squared over 25 plus y squared over 4 equals 1. Does that look like an ellipse? Is that a standard form for ellipse? Yes. So I can graph it just like I do a circle. So what's the center? 0, 0. Good. Remember, it's really x minus 0 squared and y minus 0 squared. We don't write the zeros. So the center is 0, 0. And then the number under the x tells us left and right, because x goes left and right. So the square root of 25 is 5. So that means I'm going to go right 5, 1, 2, 3, 4, 5. And left 5, 1, 2, 3, 4, 5. Okay, and under the y, I'm going to go up and down. So the square root of 4 is 2. So I'm going to go up 2 and down 2. And then I'm going to sketch in my ellipse. And that's it. That's literally as hard as I can make it. Okay? All right, how about this one? What's the center? 0, 0. Is it in standard form, first of all? Yep. There's a plus, there's a 1, we're good. So the center's at 0, 0. How far am I going to go left and right? 4, right? 1, 2, 3, 4. Because it's under the x, so that's what tells me. Now, be really careful because I don't do this very often, but once in a while, like on a standardized test or like on the ACT, the actual ACT or something, they will flip these because it's addition, so it's commutative. You could put them in any order, right? So if you don't pay attention to where the x and the y is, if the 49 were here, it's still underneath y, so it still would be up and down. Does that make sense? The one with the y goes up and down. The one with the x goes left and right, not necessarily which one's first and which one's second. Does that make sense? Okay, so just be careful of that. I don't usually do that, but once in a while you'll see on standardized tests and stuff that they want to make sure you realize what's going on there. All right, so this is left and right 4 and up and down 7. 1, 2, 3, 4, 5, 6, 7. Okay, so my ellipse goes this way. And a little bit of vocabulary, the longer axis or the longer kind of diameter we call the major axis. So I get to quit calling it diameter because I'm going to call it the major axis. Okay, whichever one's longer. Not necessarily which one's up and down or left and right, just whichever one's longer. So in this case, how long is the major axis? 14, right? 7 plus 7. And this one is called the minor axis. How long is the minor axis? 8, right? 4 and 4. Does that make sense? Okay. Here, let's do one with. Let's do one where the center isn't 0, 0. What's the center here? 4, 2, right? Remember, it's x minus h, so it's 4, 2. And then how far do I go left and right? 3. And how far up and down? 2. Hey, what do you call it when my major and minor axes are equal? A circle, right? Okay. What am I going to have to do on this one first? Divide by 1024, and then I'm going to have to divide the top and bottom by 16 to get rid of that number, and I'm going to have to divide the top and bottom by 64 to get rid of that number, because you can't have a number outside the parentheses. Does that make sense? All right, and then one other thing, if I have an equation like this, you're stressing me out because you're packing up. What number is underneath here? A 1, right? All right, don't leave without your homework.